Hey, greetings everyone. This is just going to be a short intro video into Volume by Revolution. So I found a couple cool sketches that will help get you a feel for what we're going to do, and then you're going to watch at least one more video kind of showing you how you might use this to set up problems. So here's what we have. On the left side here we have a graph of square root of x. Actually it's 2 times the square root of x, so it kind of stretches it vertically a little bit. Right now we're looking between the x values of 7 and 8, and we just have one rectangle drawn in there. Okay, and what we're going to do is, for this topic, we're going to take typically all the area under the curve here, but right now we're just looking at this little strip right here, and we're going to revolve it, rotate it around, in this case, the x-axis. So there's going to be a line that we rotated around. So I have to kind of remember a little bit what does what here. Over on this part here, you're going to see a bit more of a 3D version of what happened. So I'm going to take this rectangle and we're going to rotate it around, and I want you to think a little bit about what shape it is that you see. So we're going to rotate it around. There's the rectangle going all the way around. I want you to think about what shape you would get when you rotate that rectangle around the x-axis. Now this is a little hard maybe to view. To me, when I start sliding this, it looks like it's behind the coordinate plane right now. It's behind. Oh, we're starting to lag here a little bit. Okay, now it's directly below, and now it's coming up towards the front. Okay, and what kind of shape would we get? Well, this is going to be what it looks like. We would have a disc like that. Okay, so what we're doing here is called the disc method, and if we were to, this is actually a cylinder that we're making. So I want you to think a little bit about what we would need to know for this three-dimensional shape. We would need to know this measurement, which is the radius. Okay, and so to find the volume of this, it would be pi times the radius squared times the height. So this is kind of a sideways one. Okay, and I want you to think about what the different measurements really are. The radius is just this height right here. That's the shape that we rotated around. This is the radius. Okay, so it's this y value, and for this case, y is 2 times the square root of x. So this function ends up being the radius. We're going to have pi times the function squared, pi times the radius squared, and then the height of this is like our thickness of the strip. That's the dx. Okay, so I'm going to change this a little bit now. That's kind of the intro, but I'm going to take this and say, instead of just going from 7 to 8, okay, maybe we'll go from, we can go all the way to 0, and we technically could keep this at 8, but maybe we'll go up to 9 or 10, and you can kind of see that it grew a little bit. Okay, but the big thing here is what happens when we say, let's not just have one of these strips that we're rotating around. What happens if we have 2, or 3, or 4, or we start getting really, really skinny? You can see that we're starting, in this case, kind of starting to get a bit of a cone. But that volume, it starts to get really, really smooth. So the idea of adding more and more rectangles here, that's integration. So we're going to start off by finding that first little strip that I rotated around when there's just one rectangle, but this was from 7 to 8. And then we're going to say, let's just do that over and over again on this width right here. And so that idea of adding all these things together is the integration part. So that'll make a little bit more sense when you look at the second video. Okay, now that is mainly what I want you to be aware of. Remember, we're only looking at, let's see here. I might have to modify a few things since my internet is saying we have to refresh. See if this loads again. Otherwise, I might stop the video and just make a second one here. Anyways, that's the concept that I want you to feel very comfortable with after these 2 days are up. If for whatever reason you go on and take calculus again in college, you should at least be aware, I think, that maybe some of these other methods are useful. And so I'm going to give you some optional problems. I at least want to introduce it for you. So I'm just going to stop the video here, and then I'll get this to load and give you a second introductory video on this.